For example, significance level of 5% indicates a 5% risk of concluding that a difference exists when there is no actual difference. Lower the significance level indicates that stronger evidence is required before you are rejecting the null hypothesis. It is denoted as an alpha. There are two types of errors, type 1 error and type 2 error. Type 1 error in the sense it is the probability of rejecting the null hypothesis when it is true. It is true but you are rejecting the null hypothesis, then it is a type 1 error. It is false but you are accepting, it is a type 2 error. Now, finding the critical value. Critical value is the cutoff value which is to be compared with the test value to take a decision about the null hypothesis. It divides the graph into two sections, rejection area and acceptance area. If test value falls into the rejection area, then you should reject the null hypothesis. If the test value falls in the acceptance area, then we will accept the null hypothesis. It is derived from the level of significance of the test. It is the tabular value of a level of significance for 5% level of significance is plus or minus 1.96. So, compare the critical value with test value. If the value of a test statistic is greater than the critical value, then we reject the null hypothesis. If the value of the test statistic is less than the critical value, we do not reject the null hypothesis. And another important concept in this hypothesis testing is p-value. What is a p means? Probability. It is the probability of getting the value of our test statistic if null hypothesis is true. The lower the p-value means stronger is the evidence that the null hypothesis is false. Since p-value is a probability value, therefore it is always lies between 0 and 1. A high p-value indicate observed results are likely to occur by chance under the null hypothesis. So that's why it is called null hypothesis would not be rejected. Another hand, if low the p-value indicates that results are less likely to occur by chance under this null hypothesis. Hence, in this case, we will reject the null hypothesis. If p-value is less than 0.05, then we will reject the null hypothesis. If the p-value is greater than 0.05, we will not reject the null hypothesis. Now, tests, t-test and f-test. If sample size, if the sample is having less than or equal to 30, then we will say it is a small sample size. If the sample is more than 30, then we will say it is a large sample size. And if the population standard deviation is known and unknown. So, based on this only, we will go for either g-test or t-test. For example, if the sample size is large, means more than 30, and if you know population standard deviation are not known, then you can go for g-test. If population standard deviation is unknown and sample size is small, then you go for sample with t-test. And what is a t-test? It is a parametric test. We have discussed in parametric and non-parametric. In parametric t-test, g-test, f-test, right? So it is a parametric test. It is developed by Gossett, and it is essentially testing the significance of the difference of mean values when the sample size is small. So when the population standard deviation is not available. First, population should be normally distributed, samples are random and independent, and sample size is small, population standard deviation is unknown, then we go for this t-test. There are two types of t-tests, one sample t-test and two sample t-test. To compare sample mean with that of the population mean, you will use one sample t-test. If you have two samples, then you compare means of two different samples. Next, g-test. It is also a popular parametric test. It is used to determine whether the means are different when the population variance is known and the sample is large, means greater than 30. Population distribution should be normally distributed. It is common in parametric tests, and sample size should be large. Whether population standard deviation is known or unknown, both the cases we will use. Here also in G-test also there are two types of tests, one sample G-test and two sample G-test. To compare the mean with the population mean. Here in one sample, in the sense you have only one sample, you compare this one sample with the population mean. Then you use this one sample G-test. Two sample G-test in the sense this is also a sample and this is also a sample. In between the samples, if I want to compare the means, then I will go for G-test. And F-test, it is also called as the ratio test, and it is a popular parametric test. F-test named after the test statistic F, which named as the honor of Sir Ronald Fisher. So F-test regarded as the comparison of equality of sample variances. Simply they are called as the ratio of two variances. By changing the variance in the ratio, F-test becomes a very flexible test. It can be used then test the overall significance for a regression model, to compare the fits of different models, and to test the equality of means. And it assumes population distribution is normal, samples are drawn randomly and independently. ANOVA is another concept. Thank you very much.